Foundry, casting. Metal forming processes. The process in which no chip is removed from the workpiece, metal, is called metal forming process. Casting and forging are metal forming processes. This session deals with casting, foundry process. Foundry process, founding or casting is the process in which metallic products are made by making a mold, melting the metal and pouring into the mold cavity, allowing it to solidify, to get the shape of the product. All ferrous and non-ferrous metals and alloys can be cast. Basic steps in foundry process. Pattern making. Pattern is the facsimile, replica, of the product to be produced. Pattern exactly resembles the original product to be made. The quality of product depends on the quality of pattern making. Pattern materials. Patterns are made of wood, teak or mahogany, plaster, aluminium, its alloys, or wax. The material for making a pattern is decided based on volume of production. Aluminium is the best material for pattern making because of its light weight, low cost, easy to work and high resistance to corrosion. Types of patterns. Patterns may be of two types, i.e., solid pattern, also called single-piece pattern, and split pattern. A split pattern is made into two parts, lower and upper parts are joined, assembled in position, by means of dowel pins. Figure 1 solid, single-piece, pattern. Figure 2 split pattern. Moulding. The process of making mold cavity using a pattern in sand into which the molten metal is poured is called moulding. Moulding tools. Moulding box. It is a box of rectangular walls with both sides open. Two moulding boxes are used for making the mold. The top box is called cope, and the bottom box is called drag. Moulding board. It is a smooth wooden board on which moulding boxes are placed. Shovel. It is a pan fitted with long wooden handle. It is used to carry moulding sand from sand pit to moulding box. Riddle. It is a metal sieve used to remove small stones, nails, other impurities from moulding sand. Rammer. A rammer is used to pack sand uniformly around the pattern. Peen rammer is used near the pattern edges and mold box edges, while a round or flat rammers are used for heavy ramming on top surface of the mold. Trowels. Trowels are used for shaping and smoothing corners, and for finishing, repairing the molds. Slick. It is a spoon-shaped tool used to repair or smoothen the mold surface. Sprue pin. It is a tapered wooden piece used to make screw hole in the mold. Vent wire. It is used to poke holes in the mold to permit gases to escape after pouring molten metal. Draw spike. It is used to lift the pattern from mold. Mallet. Mallet is used to drive draw spike into the pattern to lift it from the mold. Lifter. It is used to remove loose sand which has fallen after withdrawal of pattern. Strike off bar. It is used to strike off excess sand on the top of the mold after ramming. Swab. It is used for moistening the edges of pattern before removing from the mold. Gate cutter. It is used to cut gates, passage for molten metal into the mold cavity, connecting runner and the mold cavity. Figure 3 moulding tools. Properties of moulding sand. Porosity permeability, the property by which the moulding sand permits steam and gases to escape freely from the mold after pouring the molten metal. Refractoriness, the property of moulding sand by which it can withstand high temperatures without being fused is called refractoriness. Cohesive strength, the property by which sand particles stick together to form the mold cavity and hold the shape until casting process is completed is called cohesive strength. Adhesiveness, the property by which the moulding sand sticks to the walls of mold boxes to retain the shape of mold without being collapsed is called adhesiveness. Grain size and shape, the grain shape and size should incommensurate with the surface finish of the product to be cast. Moulding processes. Depending on type of sand, moulding processes are classified as A. Green sand moulding and B. Dry sand moulding. Green sand moulding, as the name indicates, green sand is moist sand which is a mixture of silica sand, 20 to 30% clay binders and 6 to 8% moisture. The metal is poured into the mold as soon as it is made. No curing or heating baking of mold is done. This process is suitable for all ferrous and non-ferrous metals and alloys. It is least expensive, less time-consuming and suitable to make small and medium-sized castings. Dry sand molding. The procedure of making a dry sand mold is similar to that of green sand mold, but only difference is that the mold is heated baked after preparing the mold. The baking makes it stronger than green sand mold and are commonly used for large-sized castings. Molding procedure. Place mold board on a clean surface table. Place drag molding box in position and one half of the pattern in the middle of the molding box with its parting surface on molding board. Sprinkle parting sand on the pattern and its surroundings in the molding box. Prepare the molding sand and fill the drag with sufficient molding sand. Using pin and round flat rammers, pack the sand around the pattern till the mold box is fully packed with sand tightly. Invert the drag and place cope, upper molding box, over it. Place the next half pattern over it properly aligned. Place screw pins in position for screw and risers. Fill the cope with molding sand and ram until the cope is filled and packed with sand. Remove excess sand by strike of bar. Separate two molding boxes, remove screw pins, pattern from the molding boxes, poke vent holes by vent wire in cope, cut screw basin, gates to provide passage to molten metal. Assemble the boxes and the mold is ready for pouring. The metal with requisite properties is melt in the furnace. Depending on the shape, size and complexity of the design of the product, the melting temperature is decided. The metal at the temperature is poured into the mold. The casting is now allowed to cool in the mold itself. Once the mold is collapsed, a raw casting with sprue, runner, gates, etc. along with the product is obtained. The runner, gates, riser, any other projections, fins, are removed by chiseling and hammering. The casting with sand sticked on the surface is cleaned by using wire brush, sand blasting and then by grinding operations to get a smooth surface. These steps are shown in the diagrams below. Figure 4. Molding procedure. Core making. Core is a sand mass which resembles the shape of hollow portion of the casting. If we are making hollow products such as pipe fittings, flanges, etc., where the hollow portion should be restricted from entry of metal. Hence core is made and placed in position in the molding boxes before pouring the molten metal. Look at the figure below to understand the role of core in molding process. Figure 5. Position of core in the mold. Casting, melting process. We use furnaces to melt the metal for casting. If the products are small in size and number, we can use crucible furnaces which are coke or oil fired. The crucible may be stationary or tilting type furnace as shown in figure. The charge, pig iron and scrap, alloying elements, is admitted in the furnace and melted. The molten metal is collected in shank ladle, clearing the slag and any impurities. The metal is poured into the molding boxes. Figure 6. Stationary and tilting crucible furnaces. Cupola furnace. Cupola furnace is used to melt cast iron using pig iron and scrap, coke and flux charged in alternate layers. Its capacity varies from 1 to 15 tons per heat. Construction and working of cupola furnace. Construction. Cupola furnace consists of a steel shell of diameter 1 to 2.5 meter and height about 10 meters. The steel shell is lined internally with fire bricks. The shell is supported on legs. At the bottom of the shell, a drop bottom door is arranged in position by means of a prop. A sand bed, tapered, is made on the bottom door. Coke is filled up to combustion zone. Above that alternate layers of pig iron and scrap, coke and flux are added till the level of charging door. There are 4 zones, namely combustion zone, reducing zone, melting zone and preheating zone at different heights. Above all these, there is stack zone. The top of the furnace is closed by spark arrestor. Figure 7. Cupola furnace. Working. First of all, the slag and debris of previous cycle of melting is removed and the lining is thoroughly checked. The bottom door is closed by prop, Sand bottom is prepared slanting towards the tap hole. This is called preparation. Next step is firing. The coke is charged and fired using cotton waste, diesel, etc. Air is blown through the two arrays to support firing. In the next step, charging is done by alternately admitting coke, metal and flux in layers. The ratio of metal to coke is 1:8 to 1:10 by weight. Flux, fluorspar, is added to aid formation of slag to remove dust, ash, etc. from the metal and increase the fluidity of the metal. The next step is melting. The metal melts and collects at the bottom of the furnace and is ready to be tapped from tap hole. Slag is removed through the slag hole. Casting defects and causes. No. Casting defect. Causes. 1. Blowholes. High moisture, low porosity in sand, very hard ramming, insufficient vent holes. 2. Shrinkage. Incorrect pouring temperature, improper solidification. 3. Scab. Uneven ramming, high velocity pouring, quick pouring. 4. Swell. Soft ramming, quick pouring. 5. Hard spots. Rapid cooling of casting surface. 6. Run out, leakage. Faulty molding, improper parting line gating. 7. Honeycombing. Soft ramming, faulty gating or faulty pouring. 8. Cracks. Due to sharp corners edges. 9. Shift. Due to misalignment of pattern mold boxes, movement of mold boxes during pouring. 10. Poured short. Insufficient metal to fill the mold cavity. 11. Feen. Due to incorrect assembly of mold and core. Figure 8. Casting defects. Advantages of casting process. Casting is versatile process to produce any size or any shape of product. Wide range of metals and alloys of different metals can be cast. It is the cheapest, low-cost method of metal forming. Most complex shapes which are difficult to make using other manufacturing processes can be produced by casting. Rate of production is high. Hence, suitable for mass production. Prototypes can be easily produced using casting process. Disadvantages. Castings are susceptible for various defects such as blowholes, shrinkage, scab, swell, hard spots, shift, cracks, etc. It is not economical when the products are to be made in small quantities.